Greetings, fellow tech people and potential future employers. My name is Dennis, and I'm currently enrolled in TripleTen's Quality Assurance Bootcamp as I transition my career from construction into tech. I've been enjoying the process of discovering a new set of building blocks to work with, this time in a virtual environment that in its own way feels just as dynamic as a busy construction site. In this demo, I'll walk you through a project I recently completed. This assignment grew my growing foundation in software validation and test case design, while also expanding into automated testing. A powerful step towards more efficient, scalable, and thorough backend optimization. The task was to develop a complete suite of 8 automated Selenium tests for an app called Urban Routes, an application that calculates travel routes and offers various ride service options and user add-ons. I'll show you my approach, how I planned and organized the test flow, how I structured my directory and test files, the challenges I solved along the way, and how I used Python to successfully run and validate 8 unique features of this application in under 20 seconds. Let's jump in. Urban Routes is a web-based application that lets users plan and choose transportation options from one location to another, and also lets them choose between various modes of transportation ranging from driving yourself, ordering a taxi, walking, riding, a bike or a scooter, or ordering a rental car. While selecting your mode of transportation, the user is given additional options to customize their journey. With the ability to select the type of car they would like to rent and view each car's specifications, users can select the car that fits their needs the best. The type of taxi is also customizable, with options for a number of unique rider needs. Just to highlight a few examples, a rider can request that the car is office-ready with a laptop table for a more business-focused taxi ride, or a taxi can come equipped for a night out on the town with a bucket or two of ice cream in a variety of flavors and a soundproof curtain, or a customer who's ready for bed can have their ride equipped with a comfy armchair bed and a soft toy. All this and more, including sending a custom message to the driver, can be fine-tuned for each user. My goal for this project was to automate the actions required to run the app across a variety of unique scenarios, capturing every click, keystroke, and data check involved in the process. The flow begins with entering basic trip information and ends with verifying that every selected option was received and matched our expected values. Beyond that core flow, the app's add-on features gave me additional opportunities to confirm that the structure and functionality remained stable regardless of user interaction. From a QA perspective, the application and the code behind it offered a wide range of fields, formats, and variations to locate and validate, which made it a rich environment for testing. In order to run tests on our app, we first need some tools to test with, ways to use those tools, places to store those tools, and a map and agenda to tell the computer where to look for which tools at the right time. In this tool-based metaphor, the tools to test with and the ways to use them are stored in our page object model, or POM, which I have named pages.py. Our map and agenda are found in our main test file, which I have named main.py. Within my project, I also have 3 more files to support my test suite: data.py, which acted as a reference directory for constants to be stored, helpers.py, which held a function that will be required to generate a random SMS code when verifying a phone number input, and lastly, I added a file named test.py, which I used as an isolated workspace to work on the code of one test at a time before introducing it to the entire suite. For demonstration purposes, you'll notice that my demo files are prefixed by skeleton underscore or suffixed by underscore demo, not to be confused with my actual Python file names. Before gathering all the tools I needed, I found it helpful to outline the structure of my entire test suite before writing a single line of code. This pre-coding step gave me a clear worksheet that defined the purpose of each test and mapped out the steps required to complete it. I followed a similar process when setting up the structure of my POM in pages.py. This file is much simpler than main.py. It includes only a few key sections: the import statements, the class definition, a list of locators that map up to specific elements in the application, and finally, the methods that interact with these elements. Helpers.py only contains the one function, so it requires no additions or modifications. Data.py holds the values of constants such as expected values and phone numbers, but it also stores the value of the URL at which the application is located. Now that I have an outline, I am ready to start building. The first step is importing the functions, classes, and variables the program will rely on. Each import statement signals to the file where that information originates. In main.py, we're telling the program that it will run under Pytest, with Selenium providing the testing tools. We also bring in everything needed to create the WebDriver instance, along with specific pieces of data and functionality from other files, so the entire test suite has access to what it needs. Locators do exactly what the name sounds like they do. They are where to find elements within the application. Our first test, which validates entering both the to and from addresses, begins with teaching the program where to find the elements we need to interact with. Most of these are text input fields or clickable buttons, but the variety within those categories definitely made the locator scavenger hunt more interesting. Using the developer tools built into my browser, I'm able to find the location of the element within the HTML and use that code to formulate a locator by XPath, class name, or unique identifier. Methods are the skills of a program. It's the list of things that it knows how to do. As I proceed to writing the steps of each test, my main test file will need guidance on how to perform these actions. Each method defined in the POM contains an element in the application to interact with and a method of interaction. One example of a method would be locating an input field and entering text from a defined variable stored into data.py. Another would be retrieving the entered data and comparing it to our expected data. Each test acts as a checklist for the program to complete from start to finish. First, it loads an instance of our web browser within the defined class specification, loads the inputted URL, next follows a procession of methods to perform a series of actions, and conclusively checks that the information that the app produced matches with the information that we expected it to provide. For me, the most creative test in this project was the one that checked the feature allowing users to order ice creams with their taxi. It followed the standard ride ordering flow, but it introduced an additional challenge, a loop that dynamically clicked the Add Ice Cream button as many times as needed. As I mentioned earlier, I used test.py as a temporary workplace where I fine-tuned each test one at a time, confirming everything worked properly before integrating it into the full suite. At this point, our collection of locators and methods is complete and ready to be used in tests. By filling in each test step, using the methods defined in our page object model, we've assembled a clean, organized suite of 8 unique tests ready to execute. This project wasn't just about learning, although plenty of that did occur. It was about building a robust, scalable, automated testing framework from the ground up. I gained significant hands-on experience by implementing a complete QA and automation pipeline. Highlights of the skills I honed during the project include foundation and language. My automation core was built using Python with Selenium. This powerful combination allowed me to effectively mimic user interactions across various browsers. Designed for maintainability. To ensure our test suite was easy to read, update, and scale, I implemented and rigorously maintained the page object model. This architecture separates the test logic from the page structure, which is critical for long-term project health. Precision element targeting. A key focus was mastering element location. I relied heavily on browser dev tools, delving into the HTML structure to use XPath, CSS locators, class names, and unique attributes. More importantly, I practiced the skill of writing stable locators designed to withstand dynamic UI changes, significantly reducing the brittle failures common in automated tests. Test organization and execution. I structured and managed the entire test suite using Pytest. I leveraged its capabilities for efficient test management, including configuring parallel execution to run multiple tests simultaneously, dramatically cutting down the total execution time of the regression suite. The debugging mindset. And finally, when failure occurred, as they always do, I developed sharp debugging instincts. I learned to quickly diagnose test failures by employing isolated test execution and targeted logging, which allowed me to pinpoint the root cause, whether it was a bug or an automation flaw, and deploy fixes rapidly. These techniques, from structured design to POM, to parallel execution and stable locating, are the foundational skills I am confidently carrying forward. In construction, success depends on understanding how individual components integrate to form a reliable, long-lasting structure. That is the exact mindset I bring to software quality. I approach automation with a builder's mindset. It's not simply writing scripts, it's engineering predictable stability. I leverage tools like Python, Selenium, and advanced dev tools to methodically break down complex user flows, isolate potential failure points, and integrate reliability directly into the user experience. This project served as the proving ground where I successfully translate my structural, systematic thinking into a powerful, scalable automation framework. I'm not just looking for a role, I'm looking for a chance to contribute a unique perspective and technical foundation. I welcome and look forward to the opportunity to discuss how this blend of systematic thinking and technical skill can immediately benefit your team and projects, so feel free to reach out to me via email or LinkedIn. Have a great day, thanks for watching.